Good morning, good evening, guys. Good to see you all joining. So welcome to the Edureka's AWS Networking Fundamentals. And before we get started, let me introduce myself. My name is 𝐐𝐝𝐻 and I have 18 years of plus experience in IT. I have successfully trained more than 8,000 plus students on the global platforms, been associated with Edureka from last 3 years, successfully completed the AWS architect training, DevOps, and many more. So that's about me at a higher level. So officially, we are learning AWS Networking Fundamentals. So when I say about networking, one of the most important concept is the VPC, Virtual Private Cloud. So we'll talk about what VPC is, how does it work, and some other networking components of AWS. So very important question that everyone should know when they talk about networking. What is Amazon VPC? So in short, if I say what is Amazon VPC? Within public cloud, see, we all know that Amazon is a public cloud. That means anyone can create an account and start creating their resources. But when it is in public cloud, if you want to make your resources private, that can be achieved using networking. A VPC helps you to isolate your resources, prevent from bad requests, prevent from unauthorized requests, prevent from other vendor resources to connect. It isolates and make your resources to be private, not providing the internet access. We'll see how to work with VPC, some of the use cases, and some other networking concepts as we proceed further. Now, let's try to understand what is Amazon VPC. As I have said you, Amazon VPC is an networking component that makes your resources to be private in the public cloud like AWS. You have different elements in VPC like route tables, followed by your VPC, your internet gateway, your subnets, your NAT gateway, your peering connections, which will make your resources to be public and private. We'll see that how do we. The virtual private cloud is a service that lets you launch your Amazon resources, which is logically isolated, a virtual network that you define. It's like breaking a network into smaller components to utilize. Working on Amazon VPC, imagine you have a large network. When you create a network, it consists of a CRDR in say 10.0.0.0/16. Now, when you have such a large network, you need to break into smaller components, and those smaller components are called subnets. And those subnets are also availability zone specific. If you create a subnet, you can assign it to 1A availability zone, 1B behind your resources. Then you have something called route table, which officially map your internet access to the route, will help you to make your resources to connect to the internet. Like we sit at home, we have routers. If you see, if everyone has an internet at your home, that's because you have a router which is allowing your devices to connect to internet. Similarly, when you work with the networking of VPC, if you want your resources to talk to internet, you need to have a route table. The route table is the one where you determine the network traffic of your VPC to be directed. It should connect to internet, it should be private, public. You will define those rules inside the route table. Then in Amazon VPC, when you create your subnets, you can create public subnet and you can create private subnet. What is public and private subnets? Subnets are nothing but breaking the large network into smaller components. So imagine if you have a VPC of say 10.0.0.0/16. Now /16 will give you nearly 65,535 IP addresses. Right? Why? Because this is the number of hosts /16. And how did you get this host? Each number in this IP is called octet. So each number in this IP is called octet. And this octet consists of 8 bits. This is of 8 bits, this is of 8 bits, this is of 8 bits, and this is of 8 bits. So if you see 8 plus 8, 16 plus 8, 24 plus 8, 32. We all know that an IP address is a 32-bit IP address, correct? And what we are saying, I am saying like /16, which means from left to right, these two numbers are reserved. Why? 8 plus 8 is 16. Right? These two are reserved, you cannot change. Now, how many octets are free? These 2 octets are free. So 8 into 8, right? So each, in a binary language, when you write this number 8, you get 255 IP addresses in each octet.
255, 255, 255, 255 IP addresses in each octet. When you multiply this 255 into 255, you get this large number of IP addresses. Right? Each octet consists of 8 bits, and when you write in a binary language, you get 255 IP addresses in each subnet. So an IP address is combination of 255 into 255 into 255 into 255. When you are /16, these two octets are reserved. You multiply these two, you get these many IP addresses. So such a large network is this. Now you need to break this large network into smaller components. You cannot just use like that. And that's where you create subnets. You can use this third octet to break smaller components. See, these two are reserved, but this octet is free. You can get up to 251 IP addresses. Like 255 is max. 4 IP addresses are used by AWS. So you can get up to 251 ranges out of it. So what I'll do, I'll break the network into smaller components, something like 10.0.1.0/24. So what is /24? 8 plus 8 plus 8. These three are reserved. Now how many IP addresses you get from this one octet? 255 here. So this is called one subnet. Likewise, I can create 2.0, 3.0, 4.0, 5.0, up to 251 subnets. I can break this third octet into smaller components up to 251 subnets. And one subnet is equal to one availability zone. When you create, you attach it as 1A, 1B, 1A, 1B in the AWS data set. So when you create these subnets, some of them can be public subnets, some of them can be private subnets. Public means which has internet access. Private means which does not have internet access. As simple as that. When you create an application, right? When you create any application in real time, you will have 3-tier architecture. Right? Your application will be consist of 3-tier architecture. You have web layer, you have app layer, you have DB layer. Web layer will be always public. So you have 2 servers in web for high availability. It should connect to the internet. That means it should have internet access. Whereas application layer, you have 2 servers inside this, but these 2 servers should be private because the application logic is inside it. Then you have DB. Inside the DB layer, you have 2 databases. Again, tell me in the real world, anyone make the databases to connect over the internet? These DB components, these application components should be private. So you need these 4 subnets to be private and these 2 subnets to be public. So you need public-private subnets, and that's where you create. See, resources are expected to the internet using the internet gateway. When you create an internet gateway attached to the subnet, that becomes public. Similarly, when these private subnets attached to the route table which does not have internet gateway, that becomes private. So that's the logic behind. You can see here, you have an internet gateway. Internet gateway is nothing but that helps you to connect your resources to public-private. I'm creating this particular subnet in 1A availability zone. I'm creating this subnet in 1B availability. If I have an internet gateway attached, both of these subnets are public. And if one of the subnet does not have internet access, that becomes private. See, if your VPC account comes with a default VPC, the default subnet are in the availability zones which will have by default internet gateway. So all the subnets become public. But if you want to create public-private subnets, you need to create 2 route tables. One will have internet gateway attached, so it will be public, and one will have no internet gateway attached, it will be private. See, an internet gateway enables communication between resources in your VPC and internet. You can also create a peering connections. Peering connections means 2 different networks. You have 2 VPCs, and you make them to talk to each other as a single network, and that's called VPC peering. In real time, in the production environments, you have one VPC with 10.0.0.0/16. You have another VPC 192.168.0.0. Now, there are 2 different networks. Imagine if you want those resources to talk to each other. You peer them as a single network and they behave to connect over private IP addresses. And that's very much used in real time. Now, to avoid peering connections, not many numbers, AWS provide another concept called transit gateway. That's a hub and spoke model of connecting different networks over VPN connections, direct connect connections, and many more over the network. So this is a better way of managing your different networking. When I talk about a structured learning on AWS Solution Architect Training, considering about we have plans of learning AWS from Edureka. Now, what exactly this AWS training consists of? How many modules? What are the services? What are we going to learn? I'll give you a quick roadmap before we go to the demo. So we have different modules. The first module talks about introduction to the cloud. So when you join Edureka's AWS Solution Architect Training, you will be first doing an introduction to the cloud because people might know about AWS or might not know about it. So I'll be explaining you what is AWS, where it all started from, what are different regions, availability zones, and edge locations, how do we create an account, and all stuff will be a part of this. Along with, we have some hands-on to show you where you can practice. Then we talk about module 2. Officially, it is on security management in the cloud. How do organizations make their applications secure? What AWS security services are available in regards to access management, in regards to firewall, in regards to detection control, in regards to encryptions? All of them will be learning as a part of security management in the cloud. We'll do a hands-on every module, which is most like real-time training. And then we'll go to the module 3. In module 3, you have virtual machine creations. How do we create an operating system? How do we install an software inside it? How do we take the backups? How do we restore the backups? How do we share the backups to other regions? How do we create volumes inside it? How do we resize the existing volume? How to work with network-based file systems is something we want to learn about in all this particular module. And we have a hands-on placed on the top. Then we talk about module 4, storage options. So AWS provide a lot of beautiful storage services like S3, storage gateway, Snowball. So we'll talk about the different properties of an S3. S3 is one of the backbones of AWS. If you're talking about unlimited data storage in AWS, it's S3. Many organizations, in fact, when you access Netflix, when you access Amazon, when you access Amazon Prime videos, all those hundreds and thousands of video images are coming from S3, which is an unlimited data store service in cloud. It's an object-based service, and you can store unlimited data inside it. So we'll talk about more granular concepts like versioning, cross-region replication, lifecycle management, and many more as a part of it. We'll do a quick demo. Then we have module 5, load balancing, auto-scaling, and Route 53. So you will make the applications being highly available, fault tolerant, and how to use your domain name service inside the module 5. Again, a very important module, I can say, when you work as an architect. And we'll do a real-time learning on load balancing, auto-scaling, and Route 53 service. Then we'll go to the module 6. We have database services analytics. Then cloud-provided database services like RDS, DynamoDB, then Redshift, Elastic Cache. All these different types of database, how and when we will create is something we're going to learn. One of the backbones of database is RDS, one of the best services I can say, relational database service, where you can create MySQL, Oracle, PostgreSQL, Maria, and many other databases as a part of it. Module 7, we'll talk about networking and monitoring, where officially we'll learn what is VPC, how do you create public-private subnets, how do you create VPC peering connection, transit gateway, which is again a backbone of AWS learning. If you are a cloud guy and you don't know how networking works, it's very difficult. So it's very, very important to have a very clarity of understanding the components, how do you create, how do you integrate as a part. We'll have a lot of beautiful hands-on, in-depth details than what we're learning now in networking section. Then module 8, we'll talk about Lambda and application services to make your application scale, like email services, notification services, and your Lambda like serverless architecture services to understand. Module 9, configuration management automation. How do you create infrastructure as a service code? How do you use your application deployments like configuration management, Ansible, Puppet, Chef kind of services to be utilized in the cloud. Last but not the least, the migration and some DevOps additional content to learn, which can really help. Usually we do a migration concepts to learn, so we'll be doing. So this is your architecture, guys. It's not easy, and you're going to learn, very beautiful and very high-end technology learnings as a part of this training. So get excited, and if you guys register, I will be the one who's going to explain you all this concept. So let's meet up and learn these contents in a very detailed and demo-based scenarios when we start this. Then what are the different use cases of Amazon VPC when we learn VPC? See, VPCs can be used to host a simple web applications because every application should need a network to make your applications to listen to internet or make your applications to be behind internet to be private and connect securely. You can host multi-tier web applications, as I said, your web layer, app layer, DB layer to be secure. And you can also back up your important data behind your networks, which can help you to be more secure and safe. Let's talk about the other AWS networking concepts before we go to the demo. When I talk about other networking concepts, one of them is load balancer. Load balancer, we know at a high level what a load balancer. A load balancer is something that takes the user request and send to the backend nodes to process and handle it really well. Imagine if there are hundreds and thousands of requests coming to the website. Now to handle that, it can use load balancer to forward to the backend services. So round robinly, every request can be handled easily. It equally distributes the incoming traffic to the multiple EC2 instances. It can handle containers, it can handle Lambda-based services, and the load balancers are not to just handle your load, but it also helps you to achieve high value because your backend resources are built in high value. Classic load balancer, application load balancer, network load balancer. There are different types of load balancers. So we'll talk about this in depth when we join the training, right? I cannot explain all of this in a single session. So I request if you want to go and understand these concepts in depth, what classic is, what application, we will have a diagrammatic presentation and demos to be explained when we do the actual training of the solution architect. About the other networking concepts, we'll talk about direct connect. Again, a direct connect is an AWS physical MPLS connectivity. Imagine you have a data center in on and you have an application hosted in cloud. When you go to the banks and say, hey, I want to do a business, they will never allow to do over the internet. When you go and talk to the data centers in on-prem to do a business, they will deny your proposal because doing over the internet is not secure. They will deny. So what you need to tell, let's do a business over the private connectivity channel. And that's called direct. When you propose this solution, your organizations on-prem data centers will partner with you and do a lot of business over your hosted applications. Like one of the example I can say is CRED. We all know what CRED is. CRED application, talk to the bank, help you to pay your credit card bills, your statements and all. So from a mobile app, when you pay your credit card bills, indirectly that app is talking to the bank's data center and giving you the status of transaction complete, status done, retrieve the amount, how much you need to pay. So that communication is happening over private, and that is achieved using direct. It's a fiber channel MPLS connectivity laid between your on-prem to a data center. And this can be achieved with the help of direct connect partners. AWS provide direct connect partners in every region. You need to talk, provide the details, connect the path, and make this direct connect to. So this is your on-prem data center. You can host your applications in the cloud and connect privately. Then you have Route 53. Route 53 is a highly available and scalable cloud domain name system or a DNS web service. So when I talk about Route 53, I'm talking about a domain name service. When I say domain name service, every one of you would have handle or access domain. When you go to a browser, type amazon.com, facebook.com, netflix.com, you're indirectly accessing a domain, right? So domain is nothing but something that makes you to connect to your system, access and resolve your request. So usually you can buy a domain from most popular domain registers like GoDaddy, DigiCert, 123.co.res.uk and many more. Similarly, in 2016, AWS Route 53 service have become a domain registrar, and you can purchase your domains from there and map behind your load balancers, your servers, your IP addresses. So when you type that, it resolves your actual domain name and give you the beautiful access. Again, we'll learn about this when we do an official training and do the demo on this official. Route 53 is a domain name service, help you to register your domain names, route the internet traffic to the resources behind your what you map, and monitor the health of your resources with the help of dashboard provided. Now, having said that, let's take a demo on how to create a VPC and how do we create a public-private subnets as a part of it. I go to the VPC section. I might have an existing VPCs because I keep practicing, I keep demoing them. So let me delete some unwanted VPCs. In every region, AWS provide a default VPC, and the default VPC has internet gateway attached to all the subnets. So all the subnets are public. But in real time, we don't create applications all have internet access. So I'll consider that in real time, you will have applications which should be having different layers. Web tier, which should have internet access. Application and DB layer should have private access. So considering that, I'll create a VPC which should have public private subnets and attached to the route tables without internet. I'll create a VPC. I specify the name. I'll say my VPC. I'll go and create 10.0.0.0/16. I'm giving the range. The /16 is what AWS support the max. It cannot support less than this, but it can support beyond that. But this is the largest network that it will support. 65,535 IP addresses. I'll go with the default tenancy, which is good. The VPC is created, which is 10.0.0.0/16. The next thing all you need to do is you need to have the subnets being created. And as my VPC need an internet access, see my use case here is I want a VPC with public subnets and I want VPC with public private subnets. So to have a public subnet, I need an internet access. Public means internet access. So I'll create an internet gateway. An internet gateway is nothing but a logical way of creating an internet connection to your network. So AWS provide a gateway called internet gateway. You create your internet gateway with the naming convention, IVPC. I'll say IGW. The internet gateway is created. So when you create it is in a detached state, all you need to do is attach it so that you mark it to your VPC. I'll say attach. This is my VPC. The moment you attach your VPC to your internet gateway, it is connected. The next thing we need to do is create subnets. So we have VPC, we have internet gateway. Let's create these subnets. Point to be noted, when you create a subnet, all the subnets by default get attached to the default route table. The route table is something where the routes are added. And AWS has a default route table when you create a VPC. And when you create subnets, all of them get attached to it. So let me show you. I'll select my VPC. Now this is my base, and I break this particular octet into smaller components because when I say /16, these two octets are reserved. You only have the third octet to break, which can break up to 251 subnets. So I'll give a naming convention. I'll say web public 1A. I'll go with 1A availability zone. Say 10.0.1.0 is what I'm giving the naming convention. And I'm selecting the availability zone 1A because I'm giving the naming convention as well. So when you create a subnet, give a beautiful naming convention, you know what is public, what is private and all. And I'll create another web public 1B. I'm spreading each layer into high availability, 1A, 1B. And I'll give the CRDR range 10.0, this remains constant. 2.0 is what I'm creating now and say. Then you have something called app private 1A. 10.0.3.0/24. App private. 10.0.4.0/20. Similarly, I'll add one more for DB and say DB private. See, I'm creating logically a beautiful all the considering the application. You can create only one or two for your learning perspective and you can stop it. So it's not mandatory. 10.0.5.0/24. So on the availability zone, 10.0.6.0/20. So create subnets. So all the subnets got created, and as I said, when you create these subnets, all the subnets get attached to the default route table. When you create a VPC, by default VPC creates one route table called default. You see, main is equal to yes. That means this is a default route. You select this, you see all the subnets are attached to this default route table. Now imagine when you have all the subnets attached to the default route table, if you add an internet gateway here, all the subnets become public. Right? Your route table is nothing but your home. The subnets, these devices are nothing but your subnets. To your home, if you attach an internet gateway, all these devices become public. Right? If I go to routes, add a route to the route table like a router, I say I'm adding an internet gateway to the router. This is my internet connection. I say any request coming to the resources should be able to connect to the outside world. I say add. So what I did, I went to the route table, I added the internet gateway. Now, as the route table has internet gateway, this all subnets become public. You can attach any server behind the subnets. They all have internet access to listen. Is that what I want to achieve? I don't want my databases and applications to be public. I want them to be absolute private. Now, what I need to do, I'll create another route table. If you want to make your resources private, create another route table. I'll say non-default route table of my VPC. I'm creating non-default route table of my VPC. This is my VPC, and I'll give the name. The moment I give non-default route table as my VPC, see, I don't attach any route here. I say edit subnet, and whichever the subnets I want to make it private, I will select them. I say I want this, I want this, I want this, and I want this. All the DB and app I'm pulling from that subnet and attach it to this route table. Right? You see now, all those subnets are attached here. So this becomes your non-default route table. If you see non-default route table, you don't have any internet access here. Your subnets attached to them are private. Now these resources does not have any internet access. Why? Because to the route table it does not have any internet access. So that is how you create public private subnets. All you need to do is now go to the EC2 machines and create a public private resources. When you select subnets from these two will have internet access. When you create resources from these four will have no internet access. And that's what we create a VPC in here. Understood, guys? And further more demos, how to do peering connections, NAT gateways, creation of EC2 resources in the public private subnets. In depth, you will learn when you join the training. So please be a part of it, and recommend you can get 𝐂𝐝𝐿 as your trainer, so that I can be a part of your trainer and explain these concepts more beautifully with realistic demos and all. Okay. And don't forget to delete your resources, right? Test it. And if you are, you know how to create, so go back to your VPC and you can delete your resource. It's better as a part of. Yeah. Thanks everyone. Then thanks for joining the AWS Networking Fundamentals. Take care.